Hey, honors, just wanted to get you a couple more examples on 6.5. Make sure we're doing okay on some of these Lewis structures. Remember your steps, should have those in your notes for your reference. Let's take a look at a couple on that 6.5. Flip to the second page for me. Let's take a look at N2 on your second page there. Nitrogen, N2. So we go to the periodic table, we find nitrogen. It is in the fifth column, so it's got 5 valence electrons. We got 2 of them, so 5 plus 5 says we're going to have 10 total electrons to stick our molecule together. Pick a central atom, nitrogen or nitrogen. Better be nitrogen. Cool. So we put an N in the middle. There's our next step. Now we're going to go ahead and we're going to use a single bond to attach our other nitrogen. If it helps you, put the dots in there. Here's our nitrogen. We've used 2 dots. We're down to 8. Okay. Well, now what? We got 2 nitrogen stuck together. We said our next step is to fill up our outer atom. So we said this is our center. I'll put a little asterisk maybe next to that. There's our center. I've used 2. I'm going to fill up my other nitrogen. 1, 2, 3, 4, 5, 6. I'm down to 2 electrons. With my extra 2 electrons, I put them on my central atom. I've used all my dots. I am out of tape. Now the question is everybody stable? Do we have a full outer shell for everyone? Well, our first nitrogen, our outermost nitrogen is doing pretty good. It's got 8, but our central nitrogen has only got 2, 4. We're out of dots. We can't just make electrons appear. If you run short, we're going to do some extra sharing. We're going to take 2 electrons from the full one. We're going to bring them down and do a double bond. This outer nitrogen still has 2, 4, 6, 8 electrons on it. Now this nitrogen has 2, 4, 6 around it. It's closer, still a short one. We're going to go ahead and do a triple bond to make it so that everybody's got 8 valence electrons around their outer shell. Nitrogen, triply bonded, super strong. We talked about the strengths a little bit yesterday briefly. Nitrogen is about 80% of our atmosphere. Because of this triple bond holding those 2 nitrogens together, it doesn't really react. It's in our atmosphere, it's in your blood, it's all over the place, just hanging out as diatomic nitrogen. Cool, if we want to know how many bond to the center, well, really, we can't do that one here because there's not really a central atom. We'd say 0 and 0 in terms of lone pairs. We'll talk more about our shapes coming back a little bit later if we're looking at those other 4 columns. Another example that I want to show you, we got something a little bit different. Flip to that back page for me, please. We've got this weird H3O plus thing. We've got an ion. Oh, one of our polyatomic ions. Okay, these things we saw before. We're going to add them up. Our steps stay the same. The only thing we're going to have to do is kind of alter because of this positive just a little bit. But our steps are the same. Add up your valence electrons. Hydrogen's got 1. Each hydrogen's got 1 valence electron. There are 3 of them total. So 1 plus 1 plus 1, or 3 total. Oxygen has 6 in its outermost shell, but we got to take care of this 1 plus. This 1 plus means we have lost an electron, -1. If you forgot that, if you just added up as you had it here, you'd have 9 valence electrons. That's an odd number. Can't have that. It will not work. This positive means you've lost an electron for a total of 8 valence electrons. So really the charge here, just going to change our total electron count, but now the steps are exactly the same. Pick a central atom. Don't pick hydrogen. It's not very good for the center. Oxygen in the middle. I'm going to single bond to my outer atoms. I just used 2, 4, 6 electrons. I got 2 left. Next step says fill up my outer ones, but hydrogen only needs 2. Hydrogen's done, so my extras are going to go right here in the middle. Here's our structure for this molecule. Sorry, I'm trying to get above the glare there. The only other difference when it's a charged particle is we got to show that on our structure. So by convention, we put brackets and then we put the charge in the corner just to show everybody that this is a charged particle. How many atoms bound to the center? We've got 1, 2, 3 hydrogens all stuck to that oxygen. So our next column over would be 3 atoms bonded to the center. And are there any electrons on the central atom not in a bond? Well, there are. We've got 2 electrons on that oxygen. We would say this has 1 lone pair. Right now, we're just identifying these pieces, but coming back a little bit later, we'll talk about how this starts to play a factor in how the molecule actually shapes itself in 3-dimensional space. Cool. One more example for you, and then we'll be cutting you loose. Also on that last page, let's take a look at our SO4 2 minus. Oh, SO4 2 minus, that's sulfate. SO4 2 minus. SO4 2 minus. Sulfur on the periodic table's got 6 valence electrons. Each oxygen's got 6 times 4 is 24 coming from all of the O's. 2 minus means we have gained an extra 2 electrons. So we add our 2 extra electrons. Looks like 32 total electrons. Oh my goodness, gonna be a lot of dots. Like a central atom, when dot goes the first one. We got a sulfur. Sulfur for the middle. We attach our outer atoms. We got 4 oxygens to stick on there. We just use 2, 4, 6, 8 electrons. We're down to 24. Oh, it's so perfect. Each oxygen, our next step is to fill up our oxygens. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 times 4 is 24. We are out of dots. Is everybody happy? Every oxygen's got 8. Sulfur has 8 being shared with it in the bonds. Because it's an ion, we put brackets and show the charge. How many oxygens bonded to the center? Well, there's 1, 2, 3, 4 oxygens bonded to the central atom. And all of the electrons in that central atom are in a bond. So we'd say there are no lone pairs on that central atom. Again, setting us up for molecular shapes a little bit later in our unit. Cool, armed with this and with a couple more examples, we're working on the first 4 columns on the remainder of our packet. We're gonna come back and do the last 2 columns a little bit later in the unit once we've got a little bit more information.